Welcome to True Projects. In this video, we are going to explain about the project, which is crop prediction based on the characteristics of agricultural environment using various feature selection techniques and classifiers. Introduction. Crop prediction is an important aspect of agriculture because it relies on various soil and environmental factors like rainfall, humidity, and temperature. Accurate predictions help farmers to make informed decisions throughout the crop cultivation cycle, from choosing the right crops to monitoring growth and timing the harvest. Rapid and unpredictable changes in environmental conditions, including climatic change, have made it increasingly challenging for farmers to make these crucial decisions. Variability in weather patterns can significantly impact crop yields and success. Machine learning techniques have emerged as valuable tools in predicting crop yield. However, to harness their potential, it is essential to pre-process raw data effectively and transform it into formats suitable for machine learning models. Effective feature selection methods are crucial in the pre-processing stage. These methods ensure that only the most relevant features such as soil characteristics and environmental parameters are included in the machine learning model. This not only reduces computational complexity but also improves the accuracy of the predictions. Objective. The main goal of this project is to predict crop yield based on the characteristics of agriculture environment, including soil and environmental conditions such as rainfall, humidity, and the temperature. Machine learning techniques are aimed to achieve accurate crop yield prediction, taking into account the rapid changes in environmental conditions that make it challenging for farmers to make informed decisions. Effective feature selection methods are employed to pre-process raw data and ensure that only relevant features are included in the machine learning model, reducing redundancies and improving high accuracy. The project aims to compare the performance of different classifiers with the results showing that an ensemble technique offers better prediction accuracy compared to existing classification techniques. The use of recursive feature elimination helps determining the optimal number of features for the model, enhancing its performance. For implementing the project, we need requirements, and the requirements are hardware and software. Coming to hardware, operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above are needed. In software, we need Anaconda 3 and Visual Studio Community version. For implementing the project, we need few models. We have designed few models in the flow of work. The first one is importing the packages. This module involves importing necessary libraries and packages such as NumPy, Pandas, Seaborn, and Matplotlib to facilitate data manipulation, visualization, and machine learning. Exploring the dataset. In this step, we load and explore the dataset containing crop recommendation data. This includes examining its structure, columns, and initial insights into the data. Data processing and cleaning. This module uses Pandas data frame to clean and pre-process the data. It involves eliminating duplicated rows to ensure data integrity. Balancing the data may involve techniques to address class imbalance issues if they are present. Visualization of data using Seaborn and Matplotlib. This step involves creating visual representations of the data using Seaborn and Matplotlib. It includes various plots and charts to gain insights into the data's distribution, relationship, and patterns. Label encoding. It is applied to convert categorical data in string format integer format. This prepares the data for machine learning algorithms that require numerical input. Feature selection algorithm. This module encompasses various feature selection algorithms, and they are: the first one is SMOT, which is synthetic minority oversampling technique. It is a technique used to address class imbalance by generating synthetic samples of minority class. It helps balance the dataset, ensuring that recommendations are not biased towards the majority class crops. ROWS, which is random oversampling examples. It is another method for handling class imbalance by generating synthetic samples of minority class, emphasizing randomization. It is employed to create a balanced dataset, preventing the model from being skewed towards the dominant class. RFE, which is recursive feature elimination. This is the technique that recursively removes the least important features until the desired number of features are achieved. It helps in reducing dimensionality, improving model efficiency and performance by focusing on the most informative features. MRFE, which is minimum redundancy, maximum relevance. It is a feature selection method that seeks to maximize the relevance of selected features while minimizing the redundancy among them. It ensures that selected features are both relevant to the crop recommendation task and do not convey the same information, enhancing model interpretability. Boruta. It is a feature selection algorithm that extends random forest to determine the importance of features by comparing them to randomized counterparts. It is applied to rank and select the most influential features for crop recommendation, improving model accuracy. ME mode, which is multivariate empirical mode decomposition based oversampling technique. It is oversampling technique that uses empirical mode decomposition to generate synthetic samples. It is used to address class imbalance and enhance the dataset's quality for better crop recommendation performance. Splitting the data into train and test. In this step, dataset is divided into two subsets, which are training set and a testing set. Training set is used to train the machine learning models, while the testing set is reserved for the evaluation. Building the models with and without the feature selection. This is a pivotal step where various machine learning models are constructed. The first one is k-nearest neighbor. It is a supervised machine learning algorithm that assigns a class label to the data point based on the majority class among its k-nearest neighbor. It is used to classify crops based on their similarity to neighboring data points, making it suitable for recommending crops with similar environmental conditions. Naive Bayes. It is a probabilistic classification algorithm that applies Bayes' theorem with the naive assumption of independence among features. It is efficient and effective for categorizing crops by their environmental characteristics, especially in the dataset with many features. Bagging classifier. It is a machine learning technique that combines multiple Bayes models to reduce variance and improve predicting accuracy. It helps to create more robust crop recommendation models by aggregating the predictions of multiple classifiers. Random forest. Random forest is an ensemble learning method that constructs multiple decision trees during training and combines their output to make predictions. It is used to enhance the accuracy and robustness of the crop recommendation by reducing overfitting and improving generalization. Decision tree. It is a tree-like model used for classification and regression tasks where each node represents a decision based on input features. It is employed to create interpretable crop recommendation models that are easy to understand and visualize. Support vector machine. It is a supervised machine learning algorithm that finds a hyperplane classifying data into two classes, maximizing the margin between them. SVM is used to handle crop classification tasks where clear decision boundaries are needed for optimal recommendations. Gradient boosting. It is an ensemble technique that builds multiple weak learners sequentially, with each learning correcting the errors of its precedent. It is applied to improve prediction accuracy by focusing on challenging data points in the crop recommendation. Voting classifier with random forest, decision tree, and SVC. Voting classifier is an ensemble method that combines the predictions of multiple classifiers by the majority. Voting classifier leverages the strength of random forest, decision tree, and support vector machine to achieve higher accuracy and reliability in crop recommendations. Training the model. This step involves training the machine learning models using the training dataset. Each model learns patterns and the relationships within the data. Flask framework with SQLite for sign up and sign in. This module incorporates the Flask framework to create a web application. SQLite is used for user registration, which is sign up, and authentication, which is sign in, to ensure secure access to the system. User input as feature values. User input their specific agricultural conditions and preferences such as soil type, climatic conditions, and location. The given input is pre-processed for the prediction. The data provided by the user is pre-processed, which may include label encoding and formatting to match the model's input requirements. Train model is used for prediction. The pre-processed user input is fed into the trained machine learning models to predict the most suitable crops for cultivation based on the input parameters. Displaying the final outcome. The recommendation crops along with the relevant information are displayed to the user through the project's front end, allowing farmers to make informed decisions about their crop selection. This is the comparison graph of this project. Here on the x-axis we have the accuracy scores and on the y-axis we have the algorithm names. This graph represents the accuracy scores of that particular algorithm. Among all the algorithms, voting classifier is performing well, so we are using it for the predicting purpose in the web interface. For execution of the project, we need to open the code folder. This is the code folder of the project. This is the static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, which represent different pages of the website. This is the app.py file. This file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is the model file which contains the algorithmic information, and this will be loaded into project code during runtime. And this is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it popular choice for the data science. This is the sign-up file. This file is the database file used to store the user information. Now we need to copy the path from the address bar of the file explorer. Now we will copy this and open the Anaconda prompt. Using the cd command followed by the space, we will paste the copied path. This command is used to change the current directory to the code folder's path. Now we will click on enter. So the current directory is changed to the code folder's path. Here we need to type python space app.py. This will compile app.py file. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we need to click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is localhost, and the port number, unless configured differently. This is the localhost and this is the port number. Now we need to copy this local link provided by the Flask framework and paste it in any web browser. So now we will copy this link and paste it in Google Chrome. So here we will paste the link and click on enter. This is the homepage of the project which is displayed in the web browser. This front end is built by using the Flask framework. Now we need to click on sign up and enter the registration details if we are registering newly. I have already registered, so I'll directly click on sign in. So here I will enter my credentials, which are username and the password. And now I will click on so that I'll be logged in. It has redirected to the homepage of the project where we need to fill all these crop related parameters and then click on predict. By that we will have the predictions of the crops. So the nitrogen value is 89 and the phosphorus content in the soil is 47 and the potassium content is 38 and the temperature is 25.52469 and the relative humidity is 72.2485 and the pH value is 6.002525 and the rainfall is 151.887. Now we will click on predict. We have entered this value wrong, so we have to make it into a normal form. It is in the digital format, decimal format. Now we will make it into a normal format. Now we will click on predict. So it is happening with all the parameters. Now we will click on predict. So it is predicted that crop type is jute based on the sensor values. Now we will give other inputs and see what will be predicted. So here the nitrogen value is 18, phosphorus is 30, potassium is 29 and the temperature is 27, and the relative humidity is 93. pH value is 6, and the rainfall is 22.4, which is 224. And now we'll click on predict. So based on the predictions, the crop type is coconut based on the sensor values, which means he can grow coconut with those parameters. Now we'll give other parameters. Nitrogen is 90, phosphorus is 42, potassium is 43, temperature is 21, relative humidity is 82, pH value is 6, and the rainfall is 202. Now we'll click on predict. So it is predicted that the crop type is rice based on the sensor values. Now we will give other parameters. 133 is the nitrogen, and the phosphorus is 47, and the potassium is 24, and the temperature is 24, relative humidity is 79, pH value is 7, and the rainfall is 90. So it is predicted that the crop type is cotton based on the sensor values. Now we will give other soil and parameter details. Here we will give 56 as the nitrogen, phosphorus as 79, potassium as 15, temperature is 29, relative humidity is 63, pH value is 7, and the rainfall is 71. Now we will click on predict. So based on the parameters, it is predicted that the crop type is black gram based on the sensor values. In this way, we can enter all the parameter details of related to soil and the climatic conditions. Then we will have the predictions of the crop type, whether it is black gram, coconut or anything else. Now we will sign out. The project successfully developed a crop recommendation system that harnesses the power of machine learning algorithms. It simplifies the decision-making process of the farmers and assists them in selecting more suitable crops for cultivation. One of the project's primary achievements is that significant improvement in agricultural productivity. By analyzing historical data and leveraging machine learning models, the system helps farmers by optimizing the allocation of resources such as water, fertilizers, and land. Through responsible resource allocation and management, the system encourages sustainable farming practices by utilizing data-driven insights from farmers, and it can minimize waste and reduce the environmental impact on their agricultural activities, contributing to the long-term health of the ecosystem. The project has direct impact on the economic well-being of farmers by providing accurate and personalized crop recommendations. It enables farmers to make choices that can lead to higher crop yields and consequently increase income. The project's role in enhancing crop yields and optimizing resource use directly contributes to food security. As the global population continues to grow, ensuring a stable and sufficient food supply is paramount. By helping farmers producing more food with fewer resources, the system aligns with the broader goal of the global food security.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.